Okay, so here is a video on example 3 of the section 3.4 notes. It's actually taken during E period on Friday. So if we look at this example, we've got a snail that's moving a straight line path. We're asked to describe the motion, also to figure out its maximum speed and when that happens. So let's first describe the motion for all 5 paths. So initially, what's going on with the snail? It's going to be speeding up, exactly. It is at rest over here. And it definitely speeds up for that first portion. Then, what happens in the second portion? Yes, a constant speed. So it's staying at the same speed of 4. And then what happens in the third path? It's going to be slowing down for sure until it gets back to rest. So definitely at rest at both those places at 0 and 7 seconds. And it's slowing down on the third path, or basically from t equals 5 to t equals 7, it's slowing down because it was at 4 inches per minute. Now it's going down to 0. But throughout the whole time, the velocity was positive, so it was moving forward. But now, at t equals 7, what happens to the snail? It's going backwards, or turns around. And it's going to seem a little weird, but it's actually going to be speeding up from t equals 7 to t equals 10. And one way of looking at it is if you look at the speed graph, which you put side by side. If you take that portion and flip it over the x-axis, wouldn't that be the absolute value of velocity? Well, absolute value is when you take any negative y values and make them positive, right, as a transformation. So that kind of makes sense that it would be speeding up from 7 to 10, even though we're going the opposite direction. But it's going a lot in the opposite direction. In fact, it goes all the way to a certain point, and then it turns around. Or it doesn't turn around, sorry, I lied. It slows down. Then it's at rest one more time. And then it turns around at 13 and speeds up. And we're going to make some sort of connections between velocity and acceleration and the signs of velocity and acceleration, whether it's positive or negative, for each of those 7 paths after I finish going over stuff that's below this. Go ahead. No, it doesn't turn around. I was wrong about that. It starts to slow down. That's what's happening. One way to think about it is that if you draw the tangent line from 7 to 10, the tangent lines are negative. Then from 10 to 13, the tangent lines are positive. And at t equals 10, the tangent line is 0. What's a tangent line to a velocity curve? The slope of the tangent line to the velocity curve is going to be acceleration, right? So acceleration is negative to the left of 10, positive to the right of 10, and 0 at 10. So what's happening is that it kind of sounds weird, but it's changing from decelerating to accelerating. But the velocity being negative kind of makes things a little messy. So we'll clear that up in a little bit. So let's look at this stuff here. So I think we may have filled this out before. So the velocity starts, sorry, the snail starts with what velocity? It starts at 0 actually, inches per minute. And how long, and then it steadily increases in speed for how long? For 2 minutes until it gets to what? Until speed of 4. Very good. Then it travels consistently for how many minutes? Well, 3 minutes at a speed of, yeah, at a constant speed of 4 inches per minute. The snail then steadily speeds up or slows down. Slows down for about 2 minutes until it gets back to 0. At time t equals 7, the snail is at rest. Okay. Now it travels in opposite direction for how many minutes? Well, 6 minutes actually, because velocity is negative. Remember, opposite direction velocity is negative. And it does speed up until it gets to, I think it's -9. Yeah. And then it slows down until it gets back to 0. Right. Actually, you are correct. Yes, you're correct. It is 9. Because it has to be positive. It's a positive value. So at time t equals 13, the snail is at rest again. So that's that path. Then it's traveling with a steadily increasing speed. So here's the deal. Going back up over here, we use a highlighter. We're speeding up over here. Or actually, acceleration is positive. Let me take it back. Acceleration is positive. So you see how acceleration is positive from 0 to 2? And from 10 to forever? Because the slopes of the tangent lines to the velocity curve is positive, right? The slope is positive for path 1. The slope is positive from 10 to infinity. So acceleration is basically positive when slope of velocity is positive. So that's from 0 to 2 and from 10 to infinity. So that's the slopes of the tangent lines to the velocity curve is positive, as you see right there for path 1 and from 10 to forever. Our acceleration is positive. But the acceleration is negative from what to what? Yeah, we don't include 2 because it's constant. This is now when the slope of velocity is negative. Y has to be negative because, again, the slope for velocity for the slope of tangent lines to the velocity curve is change of velocity or change of time. That is acceleration, right? Remember, acceleration equals change of velocity or change of time. So of course, when your slope of your tangent lines are negative, you're going to have a negative acceleration. And that's from 5 to 10. By the way, use open intervals for this. The AP will even say so. Yeah, because the things that it just gets to be kind of ambiguous or unclear as to whether we should keep it open. Like, are you necessarily increasing at t equals 5 or 10? Like, it just gets to be unclear. They'll just tell you just use open intervals, just to not make it too confusing. Okay, so we now know where acceleration is positive and negative. It's positive from 0 to 2 and 10 to infinity. Acceleration is negative from 5 to 10. But here's where it gets interesting. It was speeding up at 2 places, right? Sorry, 3 places. Where was it speeding up? From 0 to 2. And it was speeding up from 7 to 10. And of course, speeding up from 13 to infinity. Here's the deal. You're speeding up when the velocity and acceleration are the same sign. When velocity and acceleration are both positive, think if you're going forward, positive velocity, and then your acceleration is also positive, it's pushing even faster in the forward direction. What if you're going backwards? If you're going backwards, so your velocity is negative, what if your acceleration is also negative? Wouldn't the acceleration also be pushing you more in the negative direction? So if they're the same sign, you're speeding up. If when velocity and acceleration are the same sign, you're speeding up. Now, if acceleration is working against you, if you're going the positive direction and your acceleration is negative, that's like when you hit the brakes in your car, right? When you hit the brakes in your car, you're still moving forward, but you're going not as fast, hopefully, because your brakes are slowing you down. Speed is decreasing. Speed is decreasing when they're going the opposite direction. Or if you're going backwards, but your acceleration is going the other direction, it's working against you. So your speed is decreasing when they're opposite sign. So going back up here, we were slowing down for path 3 and slowing down for a portion of path 4 from 10 to 13 because the acceleration and velocity are going the opposite directions. And lastly, if we look at the speed curve, which we flip over the part that's below the x-axis, we flip it over because now you want to make the negative y values positive if you put the absolute value on velocity. And of course, you are comparing velocity at a time, or in this case now speed, I guess. Speeding up, speed stays the same, speeding down, speeding up, slowing down, speeding up. So you can look at the speed curve to kind of match with all that. So any questions? How that works? No? Okay.